What if I told you the most expensive part of an electric car just became dirt cheap? Not through some breakthrough in lithium mining or battery recycling, but by using something you probably have sitting in your kitchen cabinet right now. The world's largest battery company, Catl, just announced they're mass-producing batteries from table salt. And the price drop is staggering. We're talking about a technology shift that could make electric vehicles cheaper than gasoline cars permanently. But here's where it gets interesting. While everyone's been fighting over lithium deposits and rare earth minerals, Catl quietly figured out how to extract the same energy storage capability from seawater, the most abundant resource on the planet. I'm your host, and this is Curiosity AI Podcast, where we explore the technologies reshaping our world. Today, we're diving deep into Catl's sodium-ion breakthrough and why it might be the tipping point that changes everything about transportation economics. Let me start with some context that will blow your mind. In 2008, if you wanted to buy a kilowatt-hour of battery storage, it would cost you $1,415. That's enough energy to power an average home for about a day and a half. By 2024, that same kilowatt-hour costs around $65 in Chinese markets. We're talking about a price reduction of more than 20 times in just 17 years. To put this in perspective, imagine if your smartphone went from costing $5,000 to $250 while becoming infinitely more powerful. That's essentially what happened to battery technology. But here's the thing. Even though these price drops seem impossible, they're about to accelerate even further. And the catalyst isn't some exotic new chemistry or revolutionary manufacturing process. It's salt, literally the stuff we put on our food. Catl, which stands for Contemporary Amperex Technology, is the company behind this breakthrough. They're not some startup with big promises. They're the world's largest battery manufacturer. They make the batteries that power Tesla vehicles, Mercedes electric cars, and millions of other EVs worldwide. When a company with that kind of track record announces they're shifting from lithium to sodium, the entire industry pays attention. Let me walk you through how dramatic this transformation really is. Catl's new Naxtra sodium-ion battery technology achieves some pretty incredible specifications. First, energy density. They're claiming 175 watt-hours per kilogram. That might sound technical, but here's what it means in practice. It's competitive with the lithium iron phosphate batteries that already power millions of vehicles. Not quite as energy dense as premium lithium batteries, but close enough for most real-world applications. Second, cycle life. This is where things get wild. Tesla's current batteries last about 3,000 to 4,000 charge cycles before they drop below 80% capacity. Catl claims their sodium batteries will last over 10,000 cycles. Think about what that means. If Tesla's battery lasts for roughly 200,000 miles of driving, Catl's sodium technology could theoretically power a vehicle for over 3 million miles before significant degradation. We're not talking about a car battery anymore. We're talking about infrastructure. Third, temperature performance. Current lithium batteries struggle in extreme cold. Anyone who's tried to start an electric vehicle in a Canadian winter knows this problem. Sodium batteries naturally handle temperature extremes better. Catl's technology operates from -40 degrees Celsius to +70 degrees while retaining 90% of its capacity. But here's the most important part, the abundance factor. Lithium is concentrated in specific geographic regions: Bolivia, Chile, Argentina, a few other places. Sodium is everywhere. It's the 6th most abundant element on Earth. We can extract it from seawater virtually anywhere. This eliminates the geopolitical complexities that currently plague battery supply chains. No more dependence on unstable regions or complex international agreements. Just seawater and industrial chemistry. Now let's talk about how Catl achieved these dramatic cost reductions. Because the technology is only part of the story. The real revolution is in manufacturing and scale. First, overcapacity and market competition. Chinese battery manufacturers built so much production capacity that supply now far exceeds global demand. When companies are fighting for survival, profit margins disappear. Prices drop to near material costs. Second, vertical integration. Catl controls everything from raw material processing to final assembly. They process the lithium, manufacture the graphite anodes, produce the cathode materials, and assemble the final battery packs. This eliminates middleman markups and reduces supply chain vulnerabilities. Third, advanced packaging technologies. Catl's cell-to-pack architecture achieves 72% volume utilization. That means less wasted space, fewer components, reduced labor costs, and ultimately cheaper batteries per kilowatt-hour of storage. Fourth, chemistry optimization. By focusing on lithium iron phosphate and now sodium, Catl avoids expensive materials like nickel and cobalt. They're using abundant iron, phosphate, and now sodium instead. Fifth, manufacturing scale. These aren't startup companies with experimental production lines. Catl operates mature factories with optimized processes. And here's the clever part. They can retool existing lithium production lines to manufacture sodium batteries using nearly identical equipment. The result is that batteries have essentially become a commodity product in China. Material costs often exceed manufacturing expenses and profit margins combined. But there's another factor most people don't understand. Catl isn't just making sodium batteries. They're also pioneering hybrid battery systems that combine multiple chemistries in a single pack. This brings us to Catl's Freevoy technology, which might be even more important than pure sodium batteries in the short term. Think of Freevoy as the Swiss Army knife of batteries. It combines different battery chemistries in a single pack. Classic lithium iron phosphate, high-performance nickel manganese cobalt, and now sodium ion. Each chemistry brings specific strengths, and Freevoy's power management system intelligently switches between them. Cold weather performance? Switch to sodium. Need maximum range for a road trip? Rely on lithium. City driving in extreme heat? Back to sodium. It's about choosing the right tool for each specific job. Since launching in October 2024, Catl has refined this technology beyond simply connecting different battery types. They've optimized cell ratios and connections to improve temperature range by 5% and extend electric range by over 10 kilometers compared to single chemistry packs. The system uses sodium as a state-of-charge benchmark to calibrate the lithium-ion battery's charge level. This improves overall system efficiency while addressing each chemistry's weaknesses with the other's strengths. 30 different vehicle models from brands including Geely, Chery, GAC, and Voya are scheduled to launch with Freevoy batteries in 2025. These aren't concept cars, they're production vehicles hitting showrooms across multiple markets. This hybrid approach represents a significant evolution from the industry's previous assumption that one battery chemistry must serve all applications. Now, I need to address something important. The internet has been buzzing with claims that Catl's sodium batteries cost as little as $10 per kilowatt hour. This figure has been repeated across social media and technology blogs. But here's the thing. Our research reveals no confirmation of this price point from any primary source. We examined official Catl announcements, industry reports, and academic research from institutions like Stanford University. None of these authoritative sources mention $10 per kilowatt-hour pricing for any Catl battery technology. The reality is impressive enough without exaggeration. Current Chinese battery prices have crashed to levels that seemed impossible just a few years ago. Energy storage system bidding in China shows prices of $65 to $70 per kilowatt-hour for complete systems. Individual lithium iron phosphate cells trade at $53 to $56 per kilowatt-hour in wholesale markets. These verified price points still represent a revolutionary achievement. The $65 to $70 figure for complete energy storage systems is more than 6 times higher than the mythical $10 price, but it's still low enough to fundamentally change the economics of electric vehicles and grid-scale energy storage. The persistence of the $10 figure highlights a broader challenge in technology journalism. The the tendency for impressive but unverified claims to spread faster than factual reporting. This phenomenon is particularly problematic in rapidly evolving fields like battery technology, where legitimate breakthroughs can seem almost impossible to outside observers. So what does this mean for the broader world? The implications extend far beyond just cheaper electric cars. First, transportation. Electric vehicles could not only reach price parity with gasoline cars, but significantly undercut them. When batteries become cheap enough, the superior efficiency of electric drivetrains creates a permanent cost advantage that internal combustion engines cannot match. Second, energy storage. Home battery systems could transition from luxury products for early adopters to standard equipment in new construction. Installing a battery backup system might cost less than high-end kitchen appliances. Third, renewable energy. Cheap batteries accelerate the deployment of solar and wind power by making grid-scale storage economically viable in most markets. The intermittency problem that has plagued renewables essentially disappears when storage becomes affordable. Fourth, geopolitics. Countries that control battery supply chains gain strategic advantages similar to those historically enjoyed by oil producers. China's current dominance in battery manufacturing could create new forms of energy dependence for importing nations. But there's also a democratizing aspect. If sodium batteries fulfill their promise, energy storage becomes accessible everywhere. No more dependence on specific geographic regions for critical materials. Catl has announced that mass production of Naxtra sodium batteries will begin in December 2025. Early adopters will likely be commercial fleets and budget-conscious consumers in emerging markets. Premium vehicles will probably stick with proven lithium technologies until sodium batteries demonstrate long-term reliability in real-world conditions. Here's the bottom line. Whether sodium batteries fulfill their promise or give way to other technologies, the trajectory is unmistakable. The expensive battery era is ending. Catl's achievements in battery cost reduction and sodium-ion technology represent more than incremental progress. They signal a fundamental transformation in global energy systems. When batteries become cheap enough to deploy everywhere, the economic advantages of electric transportation and renewable energy become overwhelming. The transition won't be immediate or uniform. Different regions will adopt new technologies at different rates. But the direction is clear. Batteries are becoming a commodity product, and that changes everything. For consumers, this means electric vehicles that cost less to buy and operate than gasoline cars. For energy systems, it means renewable power that can be stored and dispatched whenever needed. For global economics, it means a shift away from fossil fuel dependence toward electrified systems powered by abundant materials. The companies and countries that navigate this transition successfully will shape the energy landscape for decades to come. Catl's sodium battery breakthrough may be remembered as the moment when cheap, abundant energy storage became reality rather than aspiration. If you found this analysis valuable, subscribe to Curiosity AI Podcast for more deep dives into the technologies reshaping our world. And remember, in the rapidly evolving world of energy storage, today's breakthrough is tomorrow's commodity. The question isn't whether batteries will get better and cheaper. It's how fast the transformation will happen. I'm your host, and we'll see you next time on Curiosity AI Podcast.